And I'm live. That is pretty cool. Today is 1st of February 2026, Sunday, and with that, let's start not solving some problems, but today we will read about trees from the amazing competitive programmer's handbook, Tree Algorithms, chapter 14. And yes, I think I remember, I did a stream on this chapter before, but I don't remember quite a bit, and I wanted to revise, so one more stream on the same thing. A tree is a connected, yes, acyclic graph that consists of n nodes and n minus 1 edges. Yes, removing any edge from a tree divides it into two components, and adding any edge will create a cycle. Okay, cool. Yep, like yes, basic things. Moreover, there is always a unique path between any two nodes of a tree. Yes, for example, in this tree, there are 8 nodes and 7 edges. The leaves of a tree are the nodes with degree 1. Leaves of a tree are nodes with degree 1 and with only one neighbor. For example, the leaves of the above tree are nodes 3, 7, 5, and 8. For example, yes, in a rooted tree, one of the node is appointed the root of the tree, and all the other nodes are placed underneath the root. For example, in the spanning tree, node 1 is the root tree. Here we can treat node 1 as the root, or we could also have treat in any other thing as the root node. In a rooted tree, the children of a node are its lower neighbors, and the parent of a node is its upper neighbor. Each node has exactly one parent, and except for the root that does not have a parent, yes, like Batman without parents, orphan. For example, in the above tree, the children of node 2 are 5 and 6. Children of 2 are 5 and 6. Cool. The structure of a rooted tree is recursive. Each node of the tree acts as the root of a subtree that contains the node itself and all its nodes and all nodes that are in the subtree of its children. For example, yes, here we can have a subtree which starts at 2, which has 5 and 6 and 8 node. Now tree traversal. How do we traverse through a tree? DFS says, and stream is going fine. Yep. Tree traversal. General graph traversal algorithms can be used to traverse the nodes of a tree. Okay. General graph traversal. However, the traversal of a tree is easier to implement than that of a general graph because there are no cycles in the tree and it is not possible to reach a node from multiple directions. Yes, so it is a bit easier conceptually to think about a tree. The typical way to traverse a tree is to start a DFS at an arbitrary node. The following recursive function can be used. Process node S, and if node U is not E, S is the current node and I think E is the parent, and for every node that is connected to S, if the child is not equal to the parent, then call DFS on it. The function is given two parameters, the current node S and the previous node E. The purpose of the parameter E is to make sure that the search only moves to nodes that have not been visited yet. The following function call starts the search at node x0, and we are saying that 0 is not a node that is present in the first call. E equals 0 because there is no previous node and it is allowed to proceed to any direction in the tree. Yep. Dynamic programming. We can use dynamic programming for tree traversal somehow. Dynamic programming can be used to calculate some information during a tree traversal. Using dynamic programming, we can, for example, calculate n O of n time for each node of a rooted tree, the number of nodes in its subtrees, or the length of the longest path from the node to a leaf. Yes, you can do that. For each node, calculate the number of nodes in its subtree, and for each sub or for each node, what is the longest path from the node to a leaf. If you want to calculate any of this, yes, it is like, yes, dynamic programming recursive call. Whenever we are at a particular node, let's say our function is f, which takes in the index of the node for which we are looking for the longest path, let's say, and this function takes in I, a node, and gives us the longest path from that node to a leaf. So if this function is called at a leaf node, if I is a leaf, then return 0, otherwise return max of 1 plus 1 plus maximum of f for each child. Call this f function for each of the child if we are here, and call this f function for this and this, find the max and add 1 to it and return that as the answer for this thing. Yeah, it is like, yes, cool, basic dynamic programming. Hello, can you only pass the current node and maintain a visited array? Yes, we can do that. That is what we do in general graph. That is what we would do. In tree, we can either have a vector of visited nodes, or we can just pass in the parent node, because to get to a node, the only way that you can, like, since in a tree, if your tree looks like this, and if your tree is rooted, right? So let's shit, this is not rooted. Let's say your tree is rooted and this thing is the root of your tree. Then the only way that you can get back, since you are always moving down, the only way that you can get back to this node would be from the child. And if the child knows who its parent is, then this child would not go back to the parent, which you can give in the function dfs. That is like one way to do this. Or yes, generally you would have a visited array. When, yep, using dynamic programming, we can in O of n time, linear time, calculate the like size of each subtree, and also from each node what would be the like longest or the shortest distance to a edge. As an example, let us calculate for each node s a value, count s the number of nodes in its subtree. We can write a program for that. Subsize.cpp. Okay, 1 minute. Shit, not this. In just a second, I messed up a little thing. Modifier keys for the USB keyboard. Caps lock should act as control, and this is very cool because if you are using Vim, then the control key is like way down at the bottom. But if you use your caps lock as the control key, then it is pretty cool. It is easier to reach the control key that way, because you don't even, why would you need caps lock? You can just use press shift and press whatever key you want to press, and it will be written in capital letters. Let's say we have a adjacency list and we want to find out yes, vector end count, size, and include with std c plus plus dot h and using namespace std and n equals, let's say there are 10 nodes, or we can take the example given here. Let's use this one. So yep. Yep. Hello. I want to learn Golang, and can you tell me any resources? Golang. If you want to like properly learn Golang, then I would say you can read a Go programming language. This book by Brian Kernighan. Brian Kernighan is like a amazing writer, and yes, this book would be very cool. If I wanted to learn Golang, I would read this book. Let's say we have an adjacency list ADJ, where ADJ I gives us a list of children, right? And we have count n 0, where count I is the subtree size of I, node I node. Then we will have our defs function, which returns void. I think void would be cool. Int I current node and vector vector int adj and vector int reference count, and also visited. Yep. And for int x and adj I for every node that is connected to I, if not visited, if x has not been visited, int, my bad, if x is not being visited, then right. And if adj I dot size this will be connected to its parent. If adj if I is only connected to one node, which is its parent, then return 1, and also visited I equals, which is already done, visited I equals true, and count I equals 1. And here, yep, here we say count I equals 0 and count I equals max of count I, or DFS, called DFS on X ADJ count visited, and also visited X equals true, and count I is updated with return count I. That is good enough, and that will work. Fix the face. Shit, okay, something happened with the face cam. It happens sometimes, somehow. Let me see. The leaves tree algorithms, yep. Okay. And the one that they have written is very simpler compared to the one that we wrote. But okay, count S, and they are going through each node, and if U equals E, if the current node is the parent, then don't do anything. Otherwise, call DFS and count S plus equals count U, which is what we should have done instead of finding the max. Yep, because we are like taking the sum of all the nodes that are connected to this one. And how do we calculate the diameter? How do we calculate the diameter? The diameter of a tree is the maximum length of a path between two nodes. For example, consider the following tree. Consider the following tree. The diameter of this tree is 4, which corresponds to the following path, this path. Okay, note that there may be several maximum length paths in the above path. We could replace node 6 with node 5 to obtain another path with its length 4. Node 6 with 5, yep, and then we will go to 5, 2, 1, 4, 7, and still the length will be 4 because we have 4 edges. Next, we will discuss ON time algorithm for calculating the diameter of a tree. The first algorithm is based on dynamic programming, and the second algorithm uses two DFS searches. Okay, number one is a dynamic programming algorithm. A general way to approach many problems is to first root the tree arbitrarily. After this, we can try to solve the problem separately for each subtree. Root the tree arbitrarily, like from the tree, choose any random node, make that node the root, and then solve from there. Our first algorithm for calculating the diameter is based on this idea. An important observation is that every path in a rooted tree has a highest point, the highest node that belongs to the path. Thus, we can calculate for each node the length of the longest path whose highest point is the node. Okay, one of those paths corresponds to the diameter of the tree. For example, in the following tree, node 1 is the highest node on the path that corresponds to the diameter. So for 1 we will be able to see a path of length 4 and a path of length 2 and another path of length 2. We add them together and we get 4, but there would be a lot of combinations in which we could add these two together. We calculate for each node x two values: to left, to leave the maximum length of a path from x to an leaf. Okay, maximum length to a leaf, and then max length, the maximum length of a path whose highest point is x. How do we find that? Finding the maximum path to a leaf is simpler, but how do we find the maximum path where x is the highest node? For example, in the above tree, to the leaf is 2, this path on this, and the max length is 4 because there is a path 62147. 62147. In this case, max length equals the diameter. Max length equals the diameter. Working now. Yes, es funktioniert. And dynamic programming can be used to calculate the above values for all nodes in constant n. How do we calculate the maximum length path? Like, how do we calculate this? Maximum length. To calculate maximum length, we just have to take the length of the maximum path to a leaf from the current node and the length of the second longest path. Yes, and that way we will be able to find the diameter of a tree. Let's write a function. returns an integer and gives the diameter, which is the diameter, the integer is the diameter. This takes in a tree adjacency list, and we will suppose that the root is node number 1. Root is node number 1. Yep. And let's here suppose the response is 0. The longest path is of length 0. Then we will call a function highest node due to some reason, that would be the name. And for some I, vector vector in reference adj, or instead of passing these values again and again, vector vector int adj and comma and p for parent and in reference res. Yep, int reference s. And we will here have integer maximum size to 0. We have a vector of two integers and both the values are currently 0. And then for I equals for int x adj I, for every child of x, we will find the maximum length to we will find the maximum length to a leaf node, the highest, the maximum, and the second maximum length. So int highest node, this will return the maximum length to a node. Yep. And the side effect would be that this will update the res variable, but the return value would be the longest path to a leaf. Okay, so assuming that we are getting the longest path to a leaf, cmx equals, let's call this leaf long, longest path to a leaf long for x. But if x is not equal to the parent, if we are not at the parent, then int c current maximum equals leaf long for x being the current node and the parent is I and res. Now if c max is greater than or equal to maximum 0, which is supposed to be the biggest thing ever, then we will say mx1 equals mx0 and mx0 equals cmax. Else if cmax is greater than, we don't care about equal to here, if cmax is greater than mx1, in that case mx1 equals cmax. And yep, and then return cmax 0, the maximum length, and also res equals maximum of res or mx0 plus mx1. Yep, res equals 0 and leave long, call this for some any random node I whose parent is 0. 0 is does not exist, and return the response. This function will give us the diameter. All we have to do here is update the ADJ to actually represent a tree. Dot assign. Let's say this is going to have n nodes, 10 nodes, or in our example here we have 7 nodes, 7, and how can we give them here? 7 nodes. Yep, and one is shared. There are like, yes, we will have to add 12 connections. Yes. One is connected to 2, 3, and 4. Okay, will not push back 2, 3, 4, and then 2, 3, 4 are connected to 1, right? These three edges are done. 2 is connected to 5 and 6. 2 connected to 5 and 6, and then and then we have 5 and 6 connected to 2. Yep, these two nodes are done, and 4 is connected to 7. Last one. 4 and 7, 7 and 4 ADJ is also done. We can just do this, okay. Call dia for this ADJ. We don't even have to pass ADJ. We can just call the dia function. We don't even have to call the dia function, diameter function. We can just say this is 0, and we can call leaf long directly 1, 0, and rest out long compile. Hmm. I line. Let's see how many high we see. We do not see any high, which is messed up. Which it is, because it should be 8. 0 is not the answer. 0 is not the answer. Yes, we do not have a root condition, or not a root, but yeah, we do not have a condition. Yep, mx 1 plus 1 plus 2, and here written 1, but if there are no children for this node adj I or size equals 1, this is only connected to its parent. In that case, res equals maximum res or 1, and return 0. Return 0. Return 0. And here, we do have to add mx0 plus mx1, but this depends. If this thing is non-negative or non-zero, if this thing is something, then 1. Otherwise, don't add anything. And same on this. If this thing is something, then add 1. Otherwise, don't add anything. 2 is not correct. Yeah. Hello. Yes, back to English finally. And it feels like better because when I'm speaking in some other language, it is very restrictive. Hello. Nobody right now. Never. Not sublime. Never. Never. One of the best things ever. Vim, by the way. And I don't think we can call Neovim an IDE. Neovim is fundamentally a high. Yep, not an integrated development environment. It is not Neovim is not a IDE. It is fundamentally a highly extensible text editor, not an IDE. You can do whatever you want. It is not pre-configured by the people who make it. You can make it out to be whatever you want, which is cool. Hmm. I think error. Yes, error. Why are we getting two here? Why are we getting two? Plus one, but not always. If this is something, only then plus one. Yes, mx0 is something, then one, then shade. Okay, mx0 plus one here, otherwise mx0, and here also mx1 plus one, otherwise mx1. And here, if mx0 is something, only then if mx, wait, why would we add 1? We do not have to add 1. So this we will just return mx0 if it is 0 or whatever it is. That should be better, and we should get 4. We get 1, which is even worse. mx0 is the bigger one. It's not equal to p. Yep. Current is xi, and for this one, parent, this is returning something. Let's also output this 0. This is 0, which is absolutely wrong. This has a maximum height of 2 and not 0. That is wrong. This takes in 1 and ADJ. Okay, makes sense, I think. The number of edges is what we are talking about. We should make this these minus 1. Control Z, Control X to subtract 1 from a number. Okay, and here we will look if this number is greater than or equal to 0, then number plus 1, otherwise minus 1, otherwise minus 1. And also return minus 1. Minus 1 means that this is a leaf and this does not have any edges connected to it. Minus 1 is crazy. Minus 1 actually does not make sense. When we are calling this function for 5 we will return minus 1. For 6 also we will return minus 1, right? We will return minus 1, and 2 will see 5 and 6. Therefore, here we should return 0. Okay, 0 is better than minus 1, but still this is wrong. This will return 0, this will return 0, this will see and update mx1 and mx2, both would be 0, and res would be res, which is 0, or this thing which is greater than 0. So 0 would be shit, and that also plus 1. Plus 1 makes sense. Yep, plus 1 makes sense. Yeah. Oh, okay, finally. I think this works. Finally, this works. Compile, and it does not work because we are not even calling the function. Leave long from I 0 and this, and we see 4 as the correct answer. Let's change this thing a little bit. If we were to remove this 3 from here and add it to 6, we should have 5. 3 is connected to 1. We will remove that and we will say we are connecting 3 to, let's say, 7. So there has to be a connection between 3 and 7. 7, 3, 3, 7. And we should see 5 here. 5. That is cool. And if we were to remove this 5 and add this 5 to, let's say, 6, we should see a length of 6. So we are removing 5 from 6. 5 and 6 are not connected, makes sense. We are removing 5 from 2. This, and we are adding a connection between 5 and 6. 6 and 5. We should see 6, hopefully, and we do see 6. Good. So finally, this is working. Bro, get a job. Yes, I will get a job by programming. Programming is not profitable anymore. You will have to understand that unless you have a decade of experience, you won't even get a mid job I mean, I don't know. He's way too smart. Job needs him. No. What's your rating? Rating for, wait, you are a JEE aspirant. That was a very sad phase. My rating in competitive programming is right now 1350 in code forces. Okay, so this algorithm works. Maximum length and to leave. Dynamic programming can be used to calculate the above values for all nodes in O of n time. First, to calculate two leaf, we go through the children of x, choose a child C with maximum two leaf C and add 1 to its value. Then to calculate maximum length x, we choose two distinct children A and B such that the sum to this is maximum and add them together. And these two are going to be the highest return values of any two child. So, yep, that is easy. Algorithm 2. Another efficient way to calculate the diameter of a tree is based on two DFS. First, we calculate an arbitrary. First, we choose an arbitrary node A in the tree and find the farthest node B from A. Then we find the farthest node C from B. The diameter of the tree is the distance between B and C, which just somehow works. So they are saying we take any random node A and we go from that node to the node that is furthest away from A, which in this case is 5 and 6. So we, let's say we go to 6, and from there we go to the node which is furthest away from B, which is C, and they are saying that is going to be the answer from B to C. Let's implement this thing, and diameter, and this does not take in anything. We will have a BFS function, and this BFS function takes in our end and the parent by P. Yeah. This is equal to 0, no, end distance is 0 and end node is -1. This is the distance of the farthest node from the current node I, and node is just the name of the node, and -1 represents that there is no node furthest away from this current one. So for int x in adj I, for all the children of I, we are representing them by x. We will take the distance. If BFS, and not just distance, we need two things, the distance and which node is there. Yep. So this should return a pair of integers. Pair of integer or response, which is initially 0 and -1, and okay, here if x is not equal to p, if this node x, this child, this current child is not equal to the parent of I, then auto let's say answer equals called DFS on this x with I as the parent, just that. And if we see answer dot, or we can like break these two things apart, yeah, which makes more sense. Distance is 0 and end node is -1, and here we can break current distance and current node. If we see current distance is greater than distance, then we will update distance equals current distance and node equals C node, and at the end return distance and node. Okay, that is cool. This DFS works. And then auto distance and node call this DFS from 0. Parent is 1, parent is 0, right? We have the longest distance now. We don't need to know what the other node is. No, we do need to know what the other node is to call the second DFS auto dis 2 and node 2 equals DFS, called DFS on node whose parent is 0. We are starting from there. So C out, or we could even say print if the longest or the diameter is between node this and this, and its value is this, is between node 2, and the value is this 2. Return this 2 just in case, and here instead of calling this we will call dia, just call dia. We should see something, or we will see some error. Okay, it's returning a pair node distance. Usually we are assuming that the distance is 0, and then we are finding the maximum distance going through all the child of x. If x is not equal to the parent, yep, then call DFS on this node. And if current distance is greater than the actual distance, then update distance and node, and then return distance and node. Okay, so maybe at some point we are calling -1 here. Yes, and I think we might be doing that at a leaf node. No, see out this space node and line, and here also see out and line. Compile and run. 0 and -1 is again not right. 0 and -1 is not the answer. What is your age right now? 22. There is no point in learning diameter when you cannot even reach 1600. Wait, what do you mean by cannot? I have not reached 1600, but that does not limit the potential. Yes, because I want to flush. I don't just want to print a new line. So end line is something that I should be using there in this specific case. And here, hmm, TFX 1 and 0. We are calling this for 1, and for 1 we are seeing that 2 is a child and 4 is a child and 3 is a child, and on these nodes we are should not use mouse in Vim. It is a bad omen. X, yes. If X is not equal to parent, call DFS on these things and update. Like, there's nothing wrong with this. Mm, Maybe that might be the error. Maybe I don't know. When we are calling this for a leaf, or let's say we are calling this for 5, we will update distance and we will not update C node. Yes, we will not go through this whole process, right? Wait, what even is the distance? Yes, shade. Here distance is +1. Find the maximum distance and return distance +1. Why distance +1? And here one more condition for if we have adj I dot size equal to +1. If this is a leaf node, then return 0, comma minus 1. Otherwise, return distance +1. Why distance +1? Because if, let's say, the maximum length from this node to a leaf node is 1, then for this one, it would be the answer for this +1. Hmm. 3 is not right. 3 is not right. And even though we are getting here 3, why do we get node as -1? -1 does not make sense. Wait, shit. Instead of -1, here, yes, we can say I, which is the current node, which must mean a little, make a little sense. This does not make sense. Okay. 3 from 1, we are going to, why are we written? Okay. Go through each child, right? And what is each child returning? The maximum distance. Yes. What is expected of each child? 2 should return a distance of 1 and 5 as the node, right? And 5 should return 0 and 5, and 6 should return 0 and 6. 0 and 5, 0 and 6. 2 will go there, and node number 2 will call BFS on node 6 and node 5, and node 6 and 5 will return 5, will return 0 0 and 0 and 5, 0 and 6, and this would be updated to 0, which it already is 0, and this thing will return 5 and 1, which will be seen by 1. This will return 1 as the maximum distance and 5 or 6 as the node to which the maximum distance is, and then 1 will update its distance and node as 5. This should be working, but it is not. And okay, we can do a crazy thing here. Here we can like actually, which book? This is Competitive Programmers Handbook, CPH. This one, Competitive Programmers Handbook by N.T. Laksonen. This person, this book is pretty cool. We can here use debugger LLDB. Let's see how to use LLDB. I've used LLDB sometimes, but I will have to see. First of all, we have to compile this thing. So clang clang 15 subsize out with the G flag, I think. Okay, and clang 15 not on homebrew clang. Okay, that is fine. Subsize.cpp. It is better. Yes. Ah, shit. This thing. Yes. Because in Mac there is no native way to include files which are and to include libraries which are only present in GCC, because Mac uses Clang as the primary compiler. There is no like native way to include the GCC files. Therefore, this is the function G++ plus plus 15. This compiler is by Homebrew and this will include the files. No problem. No shit, this will not include the files. I think this will not include the files. We have to give additional flags to include the file. Okay. Okay, this works. This works. Where is it? LLDB out. Okay, this works. And now we have to set up breakpoints. Set a breakpoint at the main function. I think it is set up and run. It asks for our password due to some reason. Yep, now it is working. Cool. Next, next, next. Okay. Now, shit, I pressed next. At this step, I should have entered step inside, so that we would have gone inside this function. So we have to quit. Yes. Now LLDB out again. Set up a breakpoint at line 84. That works, I think. Run. Step inside. Where are we? I think it is S to step inside. Yes. Yes, it is S. And this is calling DFS. This did call DFS. Now print or current stack variables in LLDB. Frame variable. Frame variable. Frame variable, and we have a tuple shared. This is giving us the address, and to print the variable we would have to go to these addresses and see what is there. I think we can do print go to this, print this address. I think if we copy this, uh, we just see some random value. Yes. Frame variable no args to only show local variables excluding function arguments. Print variable. We could also use p address. How to print value at some address in LLDB. How to print some value at some address. Yes, this is what we were using. Okay, convert this thing first into an integer pointer and then go there. What is the type of this thing? Type is this, which is crazy. Shit, we do have the value here. Okay, my bad. We do have the value here. Print this. Yes, we do have the value here, right here. 3. 3 is not right. Let's say we move on to the next line here, and now we will step inside this DFS function, and here frame variable we have I equals 3, p equals 0, dis equals 1. Why do we have dis? And node equals 1. In any case, okay, okay, I get what is wrong. What was the name of the program? Tree size, diameter, something like that. Subsize. Subsize.cvp instead of checking this here, which does not even make sense. Right? How do we check that the current node is a leaf node? By first of all, the size has to be 1, and adj I 0 equals parent. 3 3. No. Plus 15. Yes. LLDB out. Set a breakpoint at line 84, I think it was, and run. Step inside. Step inside. Frame variable I equals 1, p equals 0. Next, dis equals 0, node equals 0. Yes, and yes. Okay, do not step inside that. If x equals I, let's see what is x. X is 2, and what is p? Print p. P is 0. So we go inside and we call DFS on x. P is 2. Sorry, x is 2. Right. And now let's step inside. Here, print I is 2, and print what? P, parent is 1. Yep. Next, 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 next. We print x. What is x? X is 1, so we will not go here. Yep. Next condition. Print x. What is now? 6. So we are from this node and we are looking at 6 as the child. Right. Step into this function. That is wrong. Frame variable I equals 6 and p equals 2. Okay, because 6 is also connected to. Okay, shit, we were, I think we were getting the wrong answer. We were getting the correct answer this whole time. Shit, at least for the three part. Because we did change the structure of this tree. We made 5, a child of 6, and we removed 6, 3, and we made 3, a child of 7. Shit, so at least we were getting the right answer in the first part. Okay, my bad. Shit. Quit. Yep. Subsize. Node and 0 go from node, and no one is the parent of this node. Now, the thing that we have to investigate is this. Why is this thing returning 0? Did we mess up something here in the inputs? No, 3 is only connected to 7, which is cool, which is okay. Shit. Oh, wait, we did change this, so okay, we changed the thing here, but not there. All right. Now this should be working, and now it is the longest. The diameter is from 3 to 5, and its value is 6, which is correct because we changed our tree. Our tree now looks like this: 6, this, then 2, 1, and 1 is connected to 4, 7, and 3. 4, 7, and 3. The longest path is from 3 to 5, but the length is not 6. 1, 2, 3, 4. Okay, length is 6. Length is 6. Cool. So we are getting the right answer. That is cool. This is an elegant method, but why does it work? It helps to draw the tree differently so that the path that corresponds to the diameter is horizontal and all other nodes hang from it. If we were to draw the path like this, then we can choose any random node. Either the random node that we do choose, it is on this longest path or it is not. If it is not on the longest path, then the node which is furthest away from these node is going to be one of the node which is on the longest path on either end of the longest path. But if we choose a node which is on the longest path, then also we will get to a node which is at either end of the longest path. And when we run our DFS again for the second time from a node which is at which the longest path ends, we will get the distance which is the longest. We will get the diameter of the tree. Cool. Node X indicates the place where the path from node A joins the path from node A joins the path that corresponds to the diameter. The furthest node from A is node B, node C, or B or C, or some other node that is at least as far away from node X. Thus, this node is always a valid choice for an endpoint for a path that corresponds to the diameter. So this just works somehow, which is cool. Cool. Some say that program is not pro. Yes. Don't worry, bro. As long as shit like you keep happening while making the web coding apps, programmers will always be in job. Yeah. Programmers will be in job because the industry would need people who can correct the security vulnerabilities of vibe code projects. Yep. Yo. Yeah, I mean, yes. But like, what would our future look like where there are no programming jobs? Who would be making the software? Like, who would be making this app where I can see PDF in black and white natively? This comes natively with Apple's viewer. My bad. Like AI is not going to do this, or even if it can, then it is not going to do it properly. How does the knight move? Shit, I will have to look it up. Bro is calling me shit. Yes, bro is. And yes, but I didn't understand this argument given by a JE person. You are a JE person. Can you understand this? Like, uh, there was a point where I wanted to print something by flushing it, and end line is the like obvious choice for flushing the output buffer. Okay, and here this looks like something cool. All longest paths. Our next problem is to calculate for every node in the tree the maximum length of a path that begins at the node. Yes, this can be seen as a generalization of the tree diameter problem because the largest of these lengths equals the diameter of the tree. Also, this problem can be solved in O of n time. How? If we just randomly choose some node as the root, then we can find the longest path choosing that random node as the root. But what if the path goes through the root? So for each node, I mean, I know this because I did do a stream about this at some point. So for each node, if we have chosen randomly this node as the root, then for this one, the longest path from this to any edge node or leaf node is going to be this one. But if we have chosen this one as the like longest, this one as the root, then we can easily get this path to one of the leaf nodes. But we don't, how do we get the path which is like back along the parent? That would be the parent would have to give something to the child, and the child would give something to the parent. The child would tell the parent the maximum length along, like in this hierarchy, when we are randomly choosing this thing as the root, and the parent will tell the child what is the maximum, the longest path that the parent has seen ever anywhere. So like this thing 2, the parent will tell the child 2, and the child will say to the parent 1. Yep, yep. But these two things depend on each other. This node would have to know that the parent has seen a length of 2, like this. But what if, but how would the parent know that the longest length is 2 before going through it? So I think the parent would have to do 2 passes over all the children. First of all, the parent will go through them and find these lengths. And then in the second path, after getting all of these lengths, the parent would also have the longest length given to it by its parent, right? Then the parent will look at what is the longest length, either the one given to the parent by its parent or the one given to the parent by one of its child, and call these child again with the longest, like longest path. Yes, and the child would then work as the parent recursively. Yes, and yeah, that is cool. That is cool. And for example, this thing would tell this child to, and this child would first of all look at its children and ask them for their longest lengths. This one will say 0, this one will say 0, and the parent would, since the parent has told this child that the longest path along it to any other place is 2. So this node has three options: 2, 0, and 0. 0, 0 along its own child and 2 along its parent. So this will uh, say that 2 is the longest length, and it will add 1 for its edge, its own edge connecting to that whatever edge is the longest, whatever path is the longest, and tell these children that, yup, I got a longest path of length 3. What do you think about it? And they will look at that 3, and since they don't have any children, so they will say that their longest length is 4, 3 plus 1. But there is a problem. This longest length given to a child from its parent, how does the child know that this longest length is not along the child itself? For example, if we didn't have this, and the longest length was along this child only, and then the parent again, when calling this child with a length of 2, it would not make sense. It would give us error. It would not be cool. The industry now require us to not rely on AI, but AI has its pros and cons. Yes, it does. And how are you able to write powers in this? Also, the numbers you are returning does not increase past 2 power 32 minus 1. Then you can do a bit packing to store both the values if you are not using any pair specific functions. If the numbers you are returning does not increase past this, then you can do a bit packing to store both the values. How? Like taking their XOR if you're not using any pair specific functions. How would I bit pack them together, two numbers? Don't use native softwares anymore. They just want to go for easy way and use JS everywhere. Don't mind him. He's either new to programming or you. Didi. Okay. Or he might be missing the context. He thought that you are continually printing something, and so shit dot 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 because you cannot write longer than this. So you are working theory, or yeah, he didn't have the context. Any good docs or resources for C++? Yes. Okay, it depends on how seriously you want to like get into it. I did the C++ programming language, and yes, I have not read this book completely. Like, of course, I don't need it completely. You can read this book, these chapters, these introductory material. Yeah, these are cool. These are cool. These are cool. You can read them, and you can read a few chapters from the standard library. Uh, these iterator algorithms and containers, and maybe even standard library summary, maybe just in case. And IO streams chapter is pretty cool. It tells us about streams, and if that is pretty cool. Maybe memory and resource. I don't remember if I read this one. Almost containers. Shit, all yes, I forgot, but I did read almost containers. Array array is not a container. It is stored on the stack. Array is a fixed size sequence of elements of a given type where the number of elements is specified at compile time. Yes, at compile time, because we want to store them at the stack. So it is not a container, it is almost a container, because a normal container can change its type, can change its size because it is stored on the heap, like a vector or a string. Uh, yes, character string, not a normal C string, but a C++ string. Churchill. Shit. who is Claire. Wait, this might be some reference. Well, this is no reference, just random people. Shit. Uh, Claire Sheridan was a British sculptor, author, and journalist who was first cousin of Sir Winston Churchill. First cousin. Okay. Though close, their relationship was tempestuous due to her bohemian lifestyle, radical admiration for communism, shit, and visits to Soviet Russia in 1920s to sculpt Bolshevik leaders. Shit. Okay, so she was a commie. We can use almost containers with functions which require containers, like fill function. Fill wants a container. We can use things which are almost containers. Bitset is also almost container. Bitset requires its time at requires its size at compile time. Constructors, constructors for almost container or for bitset. Yes. Yeah, this is a good book. You can read this. This is cool. Yes, exactly same thing. You had used pair as one of the return functions. Bitback like this minus a left shift by 32. How? So instead of using an integer, use long long. Okay, this is cool. But yeah, the thing is also to make this simple, right? This is cool and nice, and I can use this on my indie project if I want to. But this is not something that I should generally use. Here I can just write I because the other number is 0, so does not matter. And here long long answer equals this, and see this equals see this is the like number at the first place, and C node is, I can just say answer, right? And also sign and unsigned, how is this going to like, yes, change in that manner. And here answer right shifted by 32. Should this work? If I'm in doubt about this thing, answer is long long and this is int. So will I get the smallest 32 bits? I think we should. Long long convert into long long. What? Test plus one. Wh- why are they expecting something? Expression expected. Long long res equals this should go to the left. So first we have to convert this into long long. Or we could just say here that this is long long. Substitute int with, and this would work just fine. So int this would be equal to this, let's shift it 32 plus node and here return. Yes. And here unpack and long, yes. This equals rest right shifted by 32 and long node equals. Now we need the smallest bits. Yes. With the smallest bits, rest left shifted by 32, right shifted by 32. I think that should work. And I would like to do the same thing here. Answer left shifted by 32, right shifted by 32. Rest equals dfs with node and 0, dist2 and all that. Long. This is dist2, right shifted by 32. Long. Node 2 is rest 2, left shifted by 32, right shifted by 32. And this is D. Print how to print long how to in C using printf long ll. Nope, it messed up. This messed up. 3 and 5 is correct. 3 and 5 is correct, but this response is not correct. Something is wrong. ISO, yeah, ISO is pretty good docs according to me. ISO, why would you read ISO? I It is difficult for me to read even the CPP reference website for something. It says string. Nice owl. Like, look at this. This can be obscure in the string library and like all these things. These can wait since C++26. That is cool. Yeah, even this can be obscure, but reading the ISO directly is difficult. It is not necessary to read all, but you can get the topics and search it, understand the topic. Yes, you can use it as a index. Reflections in C. Okay, how do you know that there is going to be this new feature in C++26 called reflections, a library features? It is so helpful. Yes, because like I'm stupid, I do not know how some people just know things. How do you know that there is going to be, did you watch a YouTube video or maybe some notification that came to you? How do you know this? Like I genuinely want to know. The system is six, yes, mine is. The size of your integer is 64-bit. Is it? No. Maybe at the language level, size of the integer is 64 bits. Size of int, size of long. Will this work? That does work. nothing, int x, and long y. 4 and 8. Yes, shit, it did work. So no, no, the size is not like that. For integer, there are 4 bits being used, which is 32 bit. 4 bytes being used, which is 32 bits, and for long, it is 8 bytes, which is 64 bits. And some impressive performance improvements. Memory space by how much? Like, it is not required at this level when we are just reading a simple thing. It is good to know, but I think Linus Torvald does this. He optimizes at bit level. He does a lot of those things. It works like this -2 is bit 10 and 3 is binary 1 1. Yes. And so if you want to store 2 and 3 both, then you can do 2 left shifted 32. This will make, yes, 32 time, and yep, it will like uh so if I have like two numbers, one 32-bit number for 2, like you said, a bunch of zeros, then at the end 1 0. These are in total 32 bits. And for 3 also, a bunch of zeros, 0 0 0 zeros, 32 zeros, 32 bits in total. And at the end we will have 1 1. So you are saying this is 32, this is 32. Use a big number. These are ints. Use a big number, a long, which takes up 64 bits, and put both of these together. Out of these 64 bits, the first 32 bits will go to one number, and the other 32 bits will go to the other number, which is pretty cool, like mixing and stuff. And it is pretty common pattern and bit manipulation trick often used in C. It is pretty clever, especially if you want to squeeze out performance at low memory print on a MacBook. Reflection is literally the most anticipated and most demanded feature of C++ since 2020. Okay, I guess I am just living under a rock. It was expected to release in 23 but delayed to 26. If you wanted to know C++ standards and such, I would recommend to follow. What is this? Yes, you should. Yes, please recommend some good C++ channels or some resources. Is it a YouTube channel? Okay, that is a human being, Herb Shutter. He has books. That is white mode. The world's two biggest computing constraints in 2025. Who has books? Latest was parallel programming. Well, if I feel he has done more C++ than Björn Stroustrup himself, Stroustrup, even though I don't care or I don't like C++ as much as C, but I really love his compassion towards C++. Okay, I will get into him if that is a nice statement to say about someone. Herb, and he's very herbal. So we know you won't be using negative, then use unsigned. Yes, there won't be negative. So unsigned is cool. 8-bit registers stores like this too. 8 bits registers store like this too. Wait, there are like racks. Shit, there was a naming scheme, right? Why these registers are called racks or anything. I think it was like register number A, first of all. Uh, okay, so in Intel architecture, first of all, the registers were named A, register B, register C, and so on. And these were 8-bit registers, if I remember correctly. And then the name changed from RA to from A to AX, which means A extended when they became 16-bit registers. And I think then it changed to RAX when they changed from 16 to 32 bits, and now they are 64 bits. So yeah, there was some history there. Now the lower 4 bits out of 8 you are using EAX is for the lower bits amongst those, and one of the best channel for C++ is CPP-Con. Yes, bro, is a student. How was your JE exam? It was a few days ago. How was it? EAX for 32 bits and RAX for 64 bits. Yep. CPP-Con. CPP-Con. Wait, shit, I have to hide my YouTube. CPP-Con. Yep, subscribe to these people. Popular videos. Yep. High action, data-oriented design, and there was uh yeah, there are videos. There was a video by Tame Impala Obsolete. Yes. And this is cool. This is cool. There is also another strange loop conference. It's not Stranger Things. This is also cool. This is like very cool. If you know this person, Douglas Hofstadter, he is literally one of the best human beings. Jokes apart, he is one of the smartest human beings ever. Polymath. Okay, and back to this. This is not working. Can you share your GitHub? Yo. Right. It went relatively well. Chemistry was especially fucking hard. Even maths was easier than chemistry somehow. So I gave chemistry time to maths, better to do two maths questions and then potentially get -3 in chemistry. Yeah, I guess you will do fine, or maybe you will do good. You will. I mean, I cannot. Yeah, I don't know about your academics. I know you are very, very good at programming, and I guess you are. You might be good at science too. Yeah, packing, bit packing, it is called. Left shift and right shift, but this is not working somehow. Distance is the first thing, and node is the second thing. Distance is the first thing, and node is the second thing. Let's get the distance on the left, then get the node. 0 and 3. Node is correct, but distance is 0 somehow. Distance is 0 somehow. 3. How is this? 3. How is this 3? Uh, Distance left shifted by 32. 0, 0, 0, 0. Always 0. Why is the distance always 0? Distance here would be 0. Yes, correct. Because we are not adding 1. Yes, shit, we have to add 1 distance. Yep, distance plus 1. Okay, it is still 0. My bad. But since we are adding 1, so this should be working now. At least we should be getting something instead of getting nothing. 3 is wrong because why not? Shit. Yep, cool. Now it is working. Cool. Rest was not long. Rest was integer. And now the answer is 6, which is correct. Bit packing, it is called. You. Yes. High school student. Right shifting at some places. Yes. I mean, this works, right? Left shift. This part removes the like higher 32 bits. This makes them 0, and then this right shift brings the lower 32 bits which went to the higher place back to their lower place, right? I could do this, or like you are saying, I could do this thing, and you said or, but I think we can also do and of 1 long left shifted by 33 minus 1. Yes, and I think this should also work. This will give us a lot of ones. See, and where else are we unpacking things? We are unpacking things here also. Instead of this is answer. No, 2. Let's see. 11 is crazy. 33. No, shit. This should be 32. This should be 32. Substitute 33 with 32. Yep, now it is right. 6 is the correct answer. First do it on smaller examples to get hold of it. Yep, now it is working. Shit, you deleted. Now it is deleted. Never mind. Let's read the first line. My bad. I don't want to distract you more, but this is pretty interesting thing in C, the type. of the variable assigned to a structure is the same type as the first member of the structure. So um, int x and string y hello is of type int. How do we see the type of something? We can see the size, but shit, there is type of what will this say? Expression expected equals type of int. What is wanted? How to see type of variable in CPP? Type ID, type ID of I dot name. Okay, it is inside type info. Type ID dot name. Okay, include this and dot name. Compile and run, and type is hello. Maybe because of the abstraction there. No, if it will work in C plus. Okay, shit, you said in C. My bad. Because virtually not a difference between C and structure in C++. Yes, there is no difference. The only difference between a class and a structure is that in structure everything by default is public, and in class everything by default is private in C++. And there are many other differences between both. People often forget that both are two different languages. Yes. And yep. Yeah. Back to trees. Longest path is how do we find the longest path from any node, from every node to the end. Let the, as an example, consider the following tree. Let max length x denote the maximum length of a path that begins at node x. For example, in the above, max length 4 would be 3, because there is a path 4 to 1 to 2 to 6. Here is the complete table of the values. Node 0 and max length is x. Okay, for all the values. Also, in this problem, a good starting point for solving the problem is to root the tree arbitrarily, randomly. The first part of the problem is to calculate every node x, the maximum length of a path that goes through a child of x. For example, the longest path. Okay, I was thinking that maybe for each parent, first we calculate first we calculate their longest path like through their child, and then at the same time for the same parent it will look at what the value was given to it by its parent. But okay, they are saying we do these in two completely different function calls. Okay, one function call will calculate the longest path from the node to its leaves. Yep. This part is easy to solve in O of n time because we can use dynamic programming as we have done previously. Yes, then the second part of the problem is to calculate for every node x the maximum length of a path through its parent p, maximum length through the parent. through the parent. Let's say we are here, through the parent, through 1. What is the maximum length? Maximum path. Either the maximum path through 2, through a child of 2, or maximum path through the parent of 2. And yes, for parent it is easy to calculate through the parent. Yes, for calculating a path through the parent it is easy. For one does not have a parent, so its longest path would be the maximum through one of its child. Yes, and then for 2 the maximum path through its parent is going to be the maximum path through the parent of 1, which is the maximum path among the childs of 1. But the problem is that path might lead through the node, through the child for which we are looking for the path, which is not a good thing. Let's see how they solve this. Then the second part of the problem is to calculate for every node x the maximum length of a path through its parent p. For example, the longest path from node 3 goes through its parent 1. Yes. At first glance, it seems that we should choose the longest path from p. No. However, this does not always work because the longest path from a parent may go through x. Here is an example of the situation. Here, for 2, the longest path goes through 2. Still we can solve the second path in on time by storing 2 maximum lengths for each node. Max 1, the longest path, the maximum length of a path from x, and max 2, the maximum length of a path from x in another direction from the first one, from the first path. For example, in the above graph, max length 1 equals 2 using path 1 to 2 to 5, 1 to 2 to 5, and max length 2 is 1 from 1 to 4, or 1 to 3. Finally, if the path that corresponds to max length 1p goes through x, we conclude that the maximum length is maximum length, second maximum length plus 1. Otherwise, the maximum length would be the maximum length, which is actually the maximum length plus 1. Okay, so we have done 2 passes. Yeah, cool. Oh, shit, that is it. That seems to be it. Let's write a function for this. Yep. Okay, that is crazy. A lot of text. ADJ, leaf, leaf, long. Let's remove everything else. Yeah. Mm. Main, okay. And vector integer ADJ include bits dot slash std plus dot h, and using std. Okay, ADJ, n, what is n? N equals, no, n equals 1 2 3 4 5 6, n, and vector int m p dot assign, okay, and then adj dot adj bracket. How are things connected to each other in this tree? One is connected to 2, 3, and 4. One push back 2, 3, and 4, and also the opposite way 2, 3, and 4. Replace with 1, right? One connected to these, and okay, so we took care of these three things, and now just two more. 2 and 5 and 2 and 6. 2 is connected to 5 and 6. 2 is connected to 5 and to 6. Okay, and 5, 6 and 5 are connected to 2. Okay, we have our graph now. We have to work our algorithm. Vector int this size n plus 1, initially everything is equal to 0, and we will have our int dfs function which takes in I and takes in p, who is the parent, and res equals 0. Yep. And we'll check if this thing is like if this thing is a leaf, for which if comment it off, if adj bracket I dot size equals 1 and adj I 0 equals parent. If I is only connected to a node which is its parent, then we will return that the distance is 0 to the leaf node. And then for x adj I, we know that is connected to I. If x is not equal, if x is not equal to the parent, then x equals maximum of x comma I. I is the parent, and then return rest plus 1. That is cool. This thing int vector int reference dist, and here dist for I equals ref plus 1. And here also dist for I equals 0. dfs 0 comma 1 comma dist pass in dist, and now we have done the first part, but this is not the right thing to do. We need pairs, or we could use here class template argument detection pairs int. Yep. And here also we can see the same thing. Dist I is not equal to 0. Both the values are equal to 0. The longest and the second longest both are equal to 0, right? and here res is not this, it is a pair of integers. Initially, both are equal to 0. If we cannot take max like that, auto current res is for DFS with x and I and this, and if we don't want both of them, yes, a dist, and the second one we don't need. Cannot decompose non-class non-array type int. This is a pair, so we shouldn't be able to. We have to say here specifically pair if it's and 0 and semicolon. Yep, this, and if d is greater than or equal to the maximum distance right now, which is res 0 or res dot first or in first equals mx1 equals 0 and int mx2 also equals y. Why this crazy indentation? Because of this. Okay, shit. It's equal to if ds is greater than or equal to maximum 1, then maximum 2 equals mx1 and mx1 equals ds. Else if ds greater than mx2, then mx2 equals ds. We have the two maximum distances, and yes, this is wrong. Instead of this, what you will say is mx2 plus 1 and mx1 plus 1, but not always. That sometimes later on. Mx2 equals ds. Yes, that is correct, but we won't always and should not always be adding 1. We should always be adding 1. No, we should not be always be adding 1. And the maximum both are 0 makes sense. Here, uh, control X, shit, control X, control X, yes, minus 1. And if here plus what? If mx1 is smaller, greater than, equal to 0, question mark, then plus 1, otherwise, then plus 1, uh, if it is greater than equal to 0, otherwise it will be minus 1, which is okay, which is actually okay. Yes, which is okay. Yeah. So we have the maximum two distances for each node. Cool. Through DFS. Yep. For auto P in dist printf brackets one number, two numbers, new line, and also percent %t, or like indicating which node we are at, which you don't actually know. So okay, p dot first, or shit, we can use structure binding here. First and second. Is this part working? No. This means out I in line, and we do not see anything ever. We literally don't see anything ever. Why? Because of this shit. Yes. That must be the error. The size was not enough, and that is not. That is wrong. I have to charge the phone. Cool. Hello. Hello. And hello. And what are you trying to do? We are trying to find in a graph from any given node what is the longest path from that node to like any edge. Right? That is what we are trying to do. Trees. Competitive program, CP handbook. Trees. We are going through trees right now. Like back to basics. Humanity, back to basics. We were monkeys, so we were at trees. So now we are studying about trees. And screen is not stuck, which is a plus point. Okay, but and yes, for this algorithm, there are two passes, and we are facing difficulty in the first pass. In the first pass, for each node, we are calculating this dist variable, so that if we do dist I for the ith node, this will give us a pair where dist I dot first is the longest distance from I to any leaf, and like vice the same thing for dist I dot second is the second longest distance. But you might say that this is exactly what we are looking for, and so why do we have to do the second pass? Then I would say this is not what we are looking for. We this will give us, after choosing one any random node as the root, this will fill the distances with taking this node as the root node. So for 2 we would have 1 and 1 as the longest and the second longest, both are 1, which is cool. Yep. And then we will have to do the second pass for finding the better thing. Shade, okay. And no, okay, I'm not wrong, it is physics books. Yes, not David Morin has written quite a few books, generally studied by Olympiad students. Like, I don't know. This is for classical mechanics. I have not read this one. Right now, I am reading like Feynman lectures, but like, yeah, I don't want to, like, shit, I removed the thing. I do not want to speak about it because I've just started for the like 10th time, and this time I actually want to study some physics and be a scientist. Science is cool. Physics is actually cool. Okay, so we are getting wrong answer in our first part. Are we getting a wrong answer? We have chosen 1 as our root node, and for 1 we are getting 1 as the longest path and 2 as the second longest. Then for 2 we are getting 1 and 1. Okay, we are not getting the wrong answer, we are getting the right answer. Cool, shit. I just messed up with the orders here. This should be 1 and this should be 2. We are getting the right answer, so that is cool. Okay, our first path is successful. Pass is successful. We are getting their longest distance, but shit. For 1, we got 2, but how do we know that we got 2 for which node? We need to have a pair of a pair. Shit, we actually need to have a pair for a pair. Pair of a pair. We cannot just have the distance. We also need to know which child is giving this distance. For 1, we have the distance of 2 if we go through this, and a distance of 1. But you also need to know that we are getting a distance of 2 when we are at 2, and we are getting a distance of 1 when we are at 3 or 4 or something like that. So we cannot just store an integer. We need a pair of integers. And this is messed up. This is like uh, pretty messed up. Here, pair of pair. Instead of pair of pair, we could simply have a something else. We could have a tuple using p equals tuple of 4 integers, and we can say that dist is of type t, a list of type t, and this will return t, and this also takes in t. Okay, t is not here. Cool. If this is the case, then This I equals this, and the current node 0, current node. I written dist I and this distance and ng underscore underscore. Can we have two underscores? We can. I think we can have. We are just getting a warning. Node 1 equals, yeah, anything does not matter. We can say n1 equals n2 equals I, the current node. Cool. And if we see that there is a node that is better, then we will update everything. Uh, n2 n2 becomes n1 and n1 becomes node, and here n2 will become nb plus 1 for distance, and comma n1 comma n2, and yep, good enough. For auto d1 n1 d2 n2 and this, not cout but printf, um, printf %d space %d %b new line, and d1 n1 d2 n2. Compile and error because yes, 0 0, correct. Yes, but this is the wrong way. This is the wrong way. Node is there first, and the second thing is the distance. But in here, maybe we messed up in printing. We did not mess up in printing. N1 and 2, I N1 and 2. Shit, 6. Yes. Wait, no, not 6. 6 does not make sense. Yes. We don't care about ND here. Yes, we do not care about ND here. We just want to look at the distance. Yes. Yep, we do not care about ND, and this would become X, and here this would become X. That is the child which is giving us the distance. Yep, if we go to 2, we get a distance of 2. If we go to 3, we get a distance of 1. And for node number 2, if we go to 6, we get a distance of 1. And if we go to 5, we get a distance of 1. Cool. Uh, our first pass is working now for the second pass. When we are going through them for the second pass, we will look at their maximum distance either from one of their child or from their parent. Maximum distance that way. So for 1, maximum distance would be through 2. We also have the second choice. And for 2, maximum distance through the parent would be the second longest, which is through 3. Right. So I feel like we need to have like another list for keeping this secret. No, we can work with the distance that we do have, or we can make a new list. Yes, does not matter. We can make a new list, a new vector. Response, the final vector size would be n plus 1. Everything is of type T. Void, yes. Find takes in I, takes in U, the parent, and vector of type T reference called res. Okay, I if adj I dot size is equals 1 if I is only connected to one thing. Yep, and that is the parent of I. And a d j I 0 equals u. Then we know we are at a leaf node. We know we are at a leaf node, which does not make sense. Yeah, we don't care if we are at a leaf. We only care if we are at the root. If you, if not you, that means the current node has no parent. If not you, then rest shit. We also need the dist thing. Therefore, we should remove dist from here, put it here, and here say that the type is T, and then here below reassign, assign with a size of n plus 1 and T. And if that is the case, you don't even have to pass this. It will just do what? List is below, so we have to put it above as also below. Cool. And DFS is taking this, which is wrong now. Cool. We can do the same with res also. Yes. Res, and yes, we don't have to pass res in here. After this, we will say res dot assign. Yes, and we will call the find function from here. If not u, if u is 0, then yes, res. Then we will iterate through the children. Yep, those are the only choices. So for int, no, type is T. For auto, D1, N1, D2, N2 for each child. This is for each child. up. This is for each child. Uh, dist for invalid range expression. We are doing literally the same thing here, but no problem. Okay, shit. Yes. Through the child, which is the best distance. Okay, and we will also initialize for this the answer to be 0. Res for I. I think that works. Zero 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 zero. And not 0 0 0 0 for I itself. And here also I. Okay, and here if D1, we only care about D1. Do we only care about D1? We are looking at the children. Wait, we don't even have to do any of this. If this is the case, then rest I equals dist I. That's it. And then return. No. We have filled I. Now we will go to the children. For yes, we will always call this function for the children. For every child, it will be half I. If x is not equal to the parent, which is you, then find x comma I, and do this all the time. But here we have two cases. Parent, for the parent, what is the best distance? Parent or the child? For the parent, we already know have the distance in res u, but for child, we do have to see something. Depending on which one is longer, and then also which one is available. No shit. This does not have to be, yes, this does not have to be like this does not have to be like this. Yes, shit, yes. This can be, no, this will be of type T, but if I then dist, otherwise we are just looking at the parent, and if res I, not dot, but one, we cannot do this, yes, this is the error, that is of type T. If res I auto n d1 n1 d2 n2 equals res u, and then res, we'll also get all the variables for this. Let's say we will just append C to them. C n1 C d2 C n2 equals res I. C is child or current, whatever makes sense. Res I, okay. And if n1, the longest path for the parent, does not go through the current node, then we can just say res I equals res u. Else, if that is the case, then we will have to say cd1 equals d2 and cd2, and nd1 equals cd cn2 equals nd1, not n, cn1 equals n2. If that works, that works. Let's check for equality here, and if equal, just update these two, which looks a bit better, right? And then go through all the child and do the same process on them. Now, what do we have? We have for each node best path through their parent and best path through their child, which are valid. We now just have to look at which one is the longest. We'll call this parent, and we will call parent function I, 0, and we will have a separate function find, which doesn't actually do anything, and it should not do anything. We will not have a separate function. Vector end response size n plus 1. Finally, the answer for int I equals 0, I is smaller than n, I plus plus. If shit, we do have to break, so auto parent distance 1 comma parent, this distance is all that we are worried about, or yeah, we are interested in, equals dist I and child 3 4 and What is wrong with this? Auto CD1. CD1, do we already have CD1 somewhere? No, not in this scope. Cannot decompose. Non-class, non-array type value type, aka int. Int is res int. Yes, res is shit int. Res is int. So we call this final. Now let's works and final I equals maximum of PD1 parent distance 1 or CD1 child distance 1, and if this does not work I will just cry. Okay, see out final. This thing does not know how to print a vector. We'll tell it how to print a vector, and what we get is this. Wait, let's remove this. For 1 the longest distance is 2. For 2 it is saying that the longest distance is 1, which is wrong. For 2 the longest distance is 2, and for 5 and 6 the longest distance is 1, 2, 3. So yep, this does not work. Let's say instead of this we will call this function on res. What does res tell us? We do have long distances. Through parents. Shit. Okay. Okay. I do see it. I do see it. Since yes, there has to be a plus one. There has to be a plus one. For 1, this is cool. For 1, this is cool. But here, distance is the distance of the parent plus 1. I think the node does not even matter. Distance of the parent plus 1 to get to the parent. Compile and run, and we do not see the correct answer. We see the wrong answer. Distance plus 1. Wait, yes, and this and the same thing here also. 1 plus plus and yes. Okay. Yep. Cool. For 1 the answer is 2. For 3, for 2 answer is 2. For 3 answer is not 3. Answer is not 3. For 3 answer is not 3. For 5 and 6 answer is 3. For 4 also answer is 3. But no, for 3 answer is not 3. For 3 answer is 2. Shit, for 3 answer is 3. My bad. Shit. Yes, from 3 to 1 to 2 to 5. Answer is 3. Yes, cool. And yeah, so we are finally after going through all this work, 100 lines of code, we can remove this part. We can find out the longest distance that uses the ith node as the starting point to any of the leaf nodes. Yeah, this is yeah, this is a long process. Long process. Binary trees, which are the last thing in this chapter. Okay, binary trees only have two children. A binary tree is a rooted tree where each node has left and right subtree. It is possible that a subtree of a node is empty. Thus, every node in a binary tree has 0, 1 or 2 children. Yes, binary tree. For example, the following tree is a binary tree. This is a every node has either 1, 2 or 0 child. The nodes of a binary tree have three natural orderings that correspond to different ways to recursively traverse the tree. Three natural orderings, yes. Pre-order, I think pre-order is like this thing, then this, then this. First the root, no shit, it is completely wrong. Pre-order is first the root, then traverse the left subtree, and then traverse the right subtree. In order is first the left, then the root, and then the right. Okay, in order is from left to right, like we read. Pre-order is use the root first, and then post order is use the root later. First we travel to the left, then we travel to the right, and then we can go to the root. For the above tree, the nodes in pre-order would be 1 the root, and then the left. For left we look at the root 2, which is correct, and then we go to the left 4, then the right. For right the root is 5, then 6. 1 2 4 5 6 3 7. 1 2 4 5 6 3 7, yes. And then in order would be 4 2 4 2 6 5 1 3 7. 4 2 6 5 1 3 7, yes. And then post order would be 4 6 5 2 4 6 5 2 4 6 5 2 7 3 1. 4 6 5 2 7 3 1. Cool. Okay. If we know the pre-order and in order of a tree, we can reconstruct the exact tree, the exact structure of the tree. For example, the above tree is only possible with the pre-order this and this. In a similar way, the post-order and in order also determine the structure of the tree. Pre-order and in order. Pre-order and in order. Using pre-order and in order, we can uniquely identify the tree. This is like, this is there in college. And then in a similar way, if you know post order and in order, so post order and in order and pre-order and in order, so we need in order with either post order or pre-order, it works. However, the situation is different if we only know pre-order and post order of a tree. Okay, so we must need in order with either one of the other orders. In this case, there may be more than one tree that matches the ordering. For example, both of these have the same values. Okay, and pre means first we go root, then left, then right. Yes, pre is root. Yes. N means uh, left, root, and right. And post means left, right, and root. Post means right. Okay, you're telling me though, like uh, more deeper under the hood why these are called these. Pre means first, so root first, then left and right. In means in middle, so, and okay, post means end, so root in the end. That makes sense. That makes sense. And also, this would be it for the today's stream. We went through trees, and did we become better? Like, did we learn something? Yes. Yes, we did. To revise, yes, like basic tree things. And then tree traversal. Yes, the thing that we learned is finding. Well, yeah, we already, at least I already knew how to use DP in a tree to find the height of each node, height of each node from a leaf when we have a rooted tree, when our tree is rooted, and also how to find the size of the subtree. But the new thing was first of diameter. Diameter, there are two ways to calculate the diameter. Algorithm 1 uses dp. uh, yep, algorithm 1 uses dp, which is like a bit complicated, but not, yeah, which is a bit complicated. But the other algorithm we can just uses 2 DFS, and it just works. And then all longest path, and this one was the one which took most of the time, and I think we might be able to use this at some point. If we have a tree, find the maximum distance from each node to any leaf whatsoever, which is cool. And yep, for today that would be it, and thank you for being here. Bye.